1170. Compare streets by frequency of the smallest character. So for this problem, we are given a function s. So for this fs, it's going to be the frequency of the lexicographically smallest character in a non-empty string s. So let's just check what is the meaning. So for example, this s is DCCE and fs is going to be 2, because the smallest lexicographically character is going to be c, and there are two c's, so this fs is going to be 2. Yeah. So we are given an array of words. So for each of the words, we just need to calculate this function. After calculating the function, maybe inside, it's gonna be the numbers. So for example, for this word, the frequency is gonna be 3. Yeah, because the smallest character, which is a, and the frequency of a is 3. Yeah, this is gonna be the first step. So we're gonna just calculate the smallest, calculate the f function. Maybe it is 3, 4, or 5, or something else. Yeah. And we also need to calculate the queries, because we need to return an answer array, and the answer I gonna be the ith query. And for this query, we just need to check. Yeah. So for each query, the count of number of words inside the word is such that f queries I is less than fw. So this means inside the word. Yeah, so for this function fs, for this word, it's going to be 3. Yeah, so in our example, we're going to calculate all those functions and all those codes. It's going to be 3, 4, and 5, for example. So the first one is 3. Maybe, we're going to have the second one, 4 and 5. Yeah. Now we're going to answer this query. So for example, the query, for this query, for this fs, for this query, maybe fq, for this query is going to be 1. So we can use binary search to check how many numbers is going to be more than 1. So of course there are 3 numbers, and we're going to use the bisector right, because bisector right going to check the first index which is going to be more than this number 1. Yeah. So we're going to use the bisector right. So it's going to be here. So the index is going to be here. So this is going to be the I. So I equal to 0. So it means how many numbers? N minus I. N equals to the length of the array. So 3 minus 0, it is 3. It means there are going to be 3 numbers. Yeah, so this is just how we're going to solve the problem. So let's first define an f function. So inside of the function, we're going to give our word. Yeah. Let's just use a counter to check the frequency of each character. Now, we're gonna sort it the d dot case. It means we're gonna sort it all the characters. Yeah, and we're gonna choose the first character. So this is gonna be the first character. For example, in this case, it's gonna be B, and then we're gonna use the dictionary to check this character. So it's gonna be D sorted d dot case with 0. So this first character is gonna be it's going to be b, and the db going to be 1. So this is our f function. I think this is going to be easier. Now we're going to check each of the queries, and let's just prepare a final result. So for q, inside the queries, we're going to check use the binary search. So for this case, we're going to use the bisector right, because we're going to check the first character which is going to be more than this number. Yeah, because we are going to check for this query which is going to be less than the count of each of the word. Yes, the function of each of the word. Yeah, so basically this means this is our word array, and for this array we're going to use a binary search to check how many words is going to be more than the count of the query, the count of each of the query. Yeah, so let's just prepare the binary. Let's just prepare the array. So let's just use our count. It's going to be f with word for word inside the word, and after that let's just sort the array. So it's going to be the count dot sort. Yeah. Now what are we going to do? So after sorting, we're going to use this count array directly, and with the query. and the result gonna append the length of the count array minus I, which is gonna be how many words, which is gonna be more than the count of the query. Yeah. So finally, we can return the final result. Now let me just run it. What is wrong? So we cannot compare between string and integer. So what is the query? Yeah, the query is not an integer. Let's just prepare this queue. So let's just set the queue gonna equal to fq. So in this case, this queue gonna be a number. Yeah. Now as you can see, it works. Now let me just submit it. As you can see, it passed all testing cases and it's pretty fast. I think this is gonna be yeah. Although we can use the brute force to check one by one, so the time complexity is gonna be 2000 times 2000. But for this case, we just use the boundary search. It's gonna be 2000 log 2000. So definitely it's gonna reduce the time. Yeah, I think that's all about it. Thanks for watching. See you next time.